it is now 3:15, so I suggest that we start the session. Nicolina, I hope that we get the sound to work for you. Obviously, if not, maybe we can also, through the chat, do something during the discussion session. I'm sure we'll work it out. So what we'll do is I'll first start with welcome everybody to this session on design knowledge. I think we have a set of really good and interesting papers and presentations in this session. I'm really happy to see that. But I'll start with introducing all of your presenters for this session. Then Nicola will help us by showing all of the videos in one go. What I would like to encourage you, but I'm sure that now we're kind of used to it, getting to the end of this conference, is to already write your questions in the chat if you have any. You're also welcome to keep them for later and ask them via the audio and video channel, and also fine with that. And then I hope for a good discussion at the end. I think we have a quite nice set of papers that all are about, in some way, about improving quality in our field, whether it's through improving validation or by building theory in a better way. I think it will be an interesting session. So let me start by introducing maybe first briefly myself and then all of the presenters. So my name is Jaap Daalhuizen. I work at the Technical University of Denmark in the Engineering Systems Design Group. Let me just get the PV. So today we'll have 5 papers that are presented. The first one is presented by Selin Üreten from the Hamburg University of Technology, where she is a scientific researcher. Then we'll have a presentation by, or a video by Ola Isaksson, professor at product development at Chalmers University of Technology. Then we'll have a presentation by Marie-Alix Deval at the Min. Marie-Alix has first done a master in innovation technology and then has been a research engineer, and currently she is doing her she's a PhD student at the School of Min. And the subject of her research study is how to establish a strategy to run an expertise in breakthrough innovation management. Fourth, we have David Jones. He is a postdoc research associate at the University of Bristol in the Design and Manufacturing Futures Laboratory. And then last, we have the video presentation of Nicolina Dragicevic. I hope that I pronounced that okay. She holds a master's degree in organization and management from the Faculty of Economics and Business at the University of Zagreb. She joined the Knowledge Management Innovation Research Center at the Hong Kong Polytechnic University in 2014 when she entered the PhD program. And there she has developed a method for modeling and facilitating a design-based smart service innovation. And in 2017, she has started to work as a project associate on large-scale collaborative educational projects, focusing on co-creating curriculum with students in hybrid classrooms. She's interested in service innovation, in business and education, service design, and Industry 4.0. Right, so let me switch back. So I think, Nicola, we're almost ready to start the videos, and I just want to emphasize once more that please feel free to share your questions in the chat or via audio and video after the presentations. So I'm ready for the video, Nicola.
Before I start, maybe you all presenting authors could just turn off your microphones so that the sound quality is better. Thank you.
Welcome to our presentation on current challenges and solution approaches in empirical engineering design research. I am Selin Üreten. My co-authors are Matthias Eisenmann, Thomas Nelius, Enno Garrelts, Krause, and Sven Matthiesen. I would like to guide you through our workshop results, findings for an empirical research topic in 5 minutes, hopefully. So what we did was a workshop-based approach to address the following challenge. Design method validation is important in academia as well as in industry, because we can very frequently see that the design methods are not consistently used in industry, if used at all. In academia, we have the issue that the design method validation is not always reproducible and not objective, and also a hands-on approach is missing for inexperienced engineering design researchers who have either little or even no experience in social sciences, which may indeed help to come up with a valid validation. So the aim of this workshop was to identify a pool of challenges that researchers encounter nowadays in design method validation with empirical studies, and also come up with best practice ideas. So we were trying to gather all together to get some inspiration, find out some synergies, identify difficult situations, issues, and we chose the workshop-based approach because we like the idea to come up with ideas together, to elaborate on others' ideas, and a direct communication that was possible if ideas were thrown out into the discussion. The team's expertise consisted of 6 researchers coming from 3 different institutions. So the institutions are the ones you can see here in the logos, and we all have different types of studies conducted in empirical design research. So whereas some were focused on more experimental studies, some others focused on focus group interviews or observational studies. Another aspect is that some did more studies in academia and some did it more in the industrial field. And this also includes the choice of participants, whereas some studied the engineering students in their research, others studied the engineers or their participants were engineers to come up with other hypotheses, for example. The need for comparability comes from all this various experiences. So we try to find a way how we can present our solutions to each other or our challenges and our best practices in a comparable and also consistent way. And we decided to do this with the concept map, which was published last year. And it shows certain elements that need to be considered in experimental design. And let's say the first thing was to start with individual differences between the groups, then we all stick to that type of presentation. We all started with individual differences within the group. So the procedure was also that we presented all our studies and then we had the exchange of experiences to come up with challenges and best practices. So this is the list of experiences we did. We have on the left side the challenges and the best practices on the right side. This is not the full list, so please see our paper if you're interested in having more details. I just want to say that one thing we encountered was the uncertainty in participants. It is always difficult to come up with participants who have homogeneous knowledge if you want to test the design method. And this is something we can tackle with some pre-tests, for example, to check what's their pre-knowledge, or do a pre-study to see if this is actually helpful, what we did to choose our participants. We would like to thank all our study participants and researchers who provided us already on the feedback of the concept map. We are planning to do more research in this area, so please follow the ISA 21 International Workshop, which we are planning. And also you're invited to follow our research on ResearchGate. The project is called Design Method Validation. If you're interested in having more information, please feel free to contact any of us. You can also kindly contact me. You have here my email address. And just as a reminder, we are working on a project that's called Improve Validation of Methods in Product Development Through Experiments, Development of a Procedural Model, which is funded by the German Research Council. Thanks for listening. Have a good day.
Hey, and welcome to this presentation of the paper You Need to Focus to Validate by myself, Isaksson, Claudia Eckert, Massimo Panarotto, and Johan Malmqvist. We are studying the topic of validation, which has been studied many times before, and there are tons of literature and method descriptions on validation in research. In this presentation, I'd like to draw your attention to the necessity and importance of focusing your research. It has been drawn upon experiences from our own research and supervision, but also from a PhD course held at Chalmers University a couple of years ago. Validation is done based on your claims. So first, you start off with a problem, which is quite contextual, some kind of context where you define your research problem. You do your research and eventually arrive at some kind of claim. You propose a method and say that it works, for instance. Now you need to verify that it works, and that means testing that your arguments are complete and consistent. Ultimately, you then validate your research by studying if the problem has been ameliorated and if it fits to the context. Already here, we note that you need to down select and focus your problem, thereafter your actual claim that you make, and be very precise on this one. We'll come into that in a second. If you take the literature positioning first, the theoretical part, you need to find the vital few papers or knowledge pieces that are most relevant for your specific problem. If you start looking and searching for the best paper to your applied problem or your contextual problem, you may actually find that there are plenty of papers who are relevant. Hence, it's very important to start off with your research problem, which is most likely a very small portion or a specific part of the larger contextual problem. The problem is, if you don't do that, you will find very many papers that are relevant for your larger contextual problem. But when you have arrived at your specific research problem, it's likely just to be a handful of very, very specific and relevant papers. If your research problem can actually be addressed from different domains, this is also very common, and you need to pick your research angle, your specific view on addressing that specific research problems of yours. You need to find the very best papers and very best contributions already made. In the other knowledge domains relevant for the problem, it may be sufficient to look into decent reviews and textbooks even to position your work. Now, you can also look into what and where you want to contribute to. Normally, research in design contributes both to theory and to practice. The methods and means necessary to validate theoretical contributions and practical contributions are likely to differ quite significantly. Most often, you need to validate both aspects. In conclusions, we have found that it's often a challenge to validate broad problems. That means you really need to focus your work in order to validate. It's advised to first look into what you want to validate, if it's a theoretical contribution or a practical contribution, and most specifically, what is the real specific contribution and claim you're making. Once you've done that, you can also find and select the most appropriate means or method or approach to validation. We also found that it's generally better to underclaim your research rather than making broad and generalized claims. For instance, if you have studied conceptual evaluation methods for product engineering, that may be a very broad claim you're making, but if you put it slightly more contextual and narrow, down it as in the second example where you have developed a conceptual evaluation method that is applicable for thermal exhaust structure design in jet engines, it's likely that you're very much more specific and have a better chance of validating your work. And finally, I just want to thank you for your attention and hope to see you at Chalmers next year.
Hello everyone, I am Alix Deval. I am PhD student and I will present you the paper I have written with Benoit Weil and Sophie Hooge, which is Identification and Exploitation of New Design Paths by Breakthrough Innovation Experts in a Generative Design Partnership. Since 5 years, we can observe in different industries the creation of domain of expertise in breakthrough innovation management. For example, Renault, which is a French car maker, has created in 2018 the new domain innovation pattern dedicated to breakthrough innovation management. The main question of the paper is, can radical expertise in innovation be organized to identify and exploit more effectively new design paths for radical innovation? To do so, we have observed the experts in breakthrough innovation working on the Renault-Google partnership, which lead us to have an overview of the literature about the different models of generative co-exploration. We have 4 models based on the CK theory. In a nutshell, the CK theory is a design theory. There are 2 spaces, one for the concepts and one for the knowledge. Both spaces feed each other to find radical innovations. If we go back to our models, in the matching models, Company A and Company B create the CK mappings on their activities. If they have common concept or knowledge, they may explore them together. If they don't, we are in the building model. Both rework the CK mappings until finding common concept or knowledge. CK code generation, A and B creates their one CK mappings and a common CK mapping, which feeds their one CK mapping. In the ECK and TCK, the knowledge of Company A is a concept of the Company B and vice versa. So we have observed the experts in Renault using these tools, and we have discovered that the activity of the experts in breakthrough innovation contributes to exploit more effectively new design paths for radical innovation in 2 ways. First, the experts have created a new tool, a CK mapping, to identify the nature of all the kind of partnerships that could exist in a given industry. This tool can help the project or operational actors to identify the type of the current or future generative partnership and to better comprehend their impact for firms' innovation capability. Second, they generated really valuable concept for Renault and for the partnership. But what is surprising is that they did it without any exchange with Google. They have created the CK mapping for Google based on the analysis of historical material from fora, blogs, and wikis. It means that the experts use the design reasoning of current co-exploration partnership models and adapt them into new models to conduct solitary co-exploration. For example, in the matching model, Company A created CK mapping for itself, for Company B, and find common concept or knowledge. As a consequence, the result from a classic co-generation partnership would be quite different from this of the study at hand. It will also be interesting to consider the result of the CK mapping sessions realized by experts in breakthrough innovation from both companies. Thus, we can wonder if the experts in breakthrough innovation can coordinate the other experts to identify new innovation. We have 2 inceptions. First, we are interested to see if experts in breakthrough innovation management may organize an exploration ecosystem constituted by internal and external experts from different firms. Meeting of experts from different firms should be organized in a specific space to support and improve the exchange on emerging expertise fields and to allow the creation of tools upstream partnership from the strategic development and the design of innovative paths. The second assumption is to consider that the experts of breakthrough innovation management are experts of the unknown, and the aim is to support the other experts in the unknown. I am exploring this question, and I hope I will present you the result very soon. Thank you for your attention, and have a nice day.
Hello, my name is David Jones. I'm from the University of Bristol's Design and Manufacturing Futures Lab, here today presenting our work on the framing of design as the pathways between physical, virtual, and cognitive models. To start with the motivation behind this work, the proto-twinning project at the University of Bristol is looking at the transitions between physical and virtual artifacts in engineering design. So that transition between a virtual CAD model, a physical 3D printed lump of plastic, modifying that lump of plastic and going back to some kind of virtual representation of it, be it a 3D point cloud or an updated CAD model. So we're looking at trying to automate that tool chain, and as a result, improve the way designers design. So that aspect of virtual and physical twinning lends itself to the digital twin literature. So we did a review of that space and discovered this gap in the knowledge in terms of how one aligns the conceptual design, a conceptual design, with the twinning of physical and virtual models. So the motivation behind this work was understanding and hopefully filling that gap. We start with the Open University course material on design does a really good job of describing design in terms of the three types of model used: physical, clay, virtual CAD, cognitive idea. So we kind of took this and thought, well, can we describe or frame design in terms of the transitions between these types of models? So if you have a cognitive model and you turn that into a physical model, you engage in something like sketching or fabrication. If you have a physical model and you go into a virtual model, you engage in something like laser scanning it or measuring that lump of plastic with a digital caliper and entering its geometry into a CAD package. Similarly, if we take physical to a cognitive model, you're giving your 3D printed lump of plastic to an end user and they're giving their thoughts on that design back to you. When you can step back and look at this as a design process as a whole, design starts with a design problem, it ends with a design solution. And you can see that actually, yes, you can frame it in terms of the types of models made and the pathway between them. So you start with a cognitive idea, you then explore that idea with a physical sketch. That physical sketching, that exploration of that idea ends in a annealed concept, a stronger cognitive model. That cognitive model can then be captured in a virtual CAD model. That virtual CAD model can then be made physical through 3D printing. That 3D printed artifact can then be used to update the cognitive model through learning. And then that process carries on until you reach a design solution. But how does this align with design science and some of the key theories in design science? So the paper goes into a bit more detail in this, but if we take a few examples, say wayfaring. Wayfaring talks about how designers take steps or iterate towards a design solution. With every iteration, they learn about the design problem and evolve that design solution. And if we kind of go that pathway between a cognitive model to a, say, sketching physical model and back to the cognitive model, that perfectly aligns with the wayfaring description of iteration and understanding and learning. If we take something like private processes and public images, Goldschmidt and Porter talk about having the right models for the right job. Part of that theory talks about that. So you can see that in terms of selecting the right physical, virtual, cognitive model for the application in hand or the problem in hand. And then, say, conversation with materials talks about designers examining, taking action, and then reflecting on that. Well, that's almost this cognitive to a virtual or physical model, and then back to a cognitive model again. So we've shown, to conclude, this paper showed the framing of designers' pathways between physical, virtual, and cognitive models. And we've shown that it does align with some of the seminal works in design science, but there is future work required, both in that alignment. So we didn't look at prototyping for X, for example, and we only briefly touched on function FBS purely because there wasn't space in the paper to go into any real detail. So that work still needs to be done. Some interesting questions that were raised from both the reviewers and within the group ourselves in terms of what do those transitions look like? What do those pathways look like in real world projects? Is it possible to prescribe when a certain model or pathway should be used, and how would one would evaluate a formal model? But if we finish off by returning to that opening question, how do the conceptual designs align with twinning of physical and virtual models? What we've shown is in design, cognitive models are naturally captured through the designer's creation of physical and virtual models. Once those physical and virtual models exist, they can effectively be twinned, or they can be twinned, effectively capturing that cognitive model. Thank you for listening, and I hope you found the presentation interesting.
Hello everyone, my name is Nikolina Dragicevic, and today I will present to you research on modeling the generative power of service design practice through the refined language of the CK theory. CK theory is one of the most comprehensive and formally defined accounts of the design logic. It was developed by Hooge and Weil in their papers. It was used in different design projects, and it has multiple extensions. However, our literature review reveals that focus of CK theory is on conceptualizing design of products, and it has limited ability to analyze and describe design of service. If you think about service, it involves multiple actors, their interactions, and in some conditions, social and technical conditions of these interactions. Therefore, according to the problematic undertaken in this research, the main question is about how can we model service design by extending the formal language of CK theory and account for properties of service practice. To answer this question, we have formed three impartial objectives, which we will go through in the next slides. Our first step was to define relevant constructs for service practice, and for this purpose, we have reached to contemporary service literature, in particular service dominant logic developed by Vargo and Lush, and social theory by Giddens, on which recent service dominant papers heavily rely on. There are three main constructs which focus on actors' interactions for the purpose of satisfaction of their needs. These actors are service providers and customers, but could also involve different stakeholders, others. Our next step was to embed these constructs into CK theory formal language. However, let's have a look first at the original framework. It is composed of knowledge space and the concept space. And for example, in the ideation process, properties are taken from the knowledge or known space to form new concepts in a concept space. In our extended CK theory formal framework, knowledge space accounts for multiple actors and multiple knowledge of these actors. For example, service providers and customers. If you imagine that they are invited to the ideation workshop where they co-create new service concepts. Our model also accounts for the interaction space, which is governed by different rules of interactions due to the socio-technical conditions. Hence, our main proposition is that properties are added from knowledge space to concept space through sense-making functions which link these different knowledge spaces in emergent properties, and that for these reasons, new concepts are emergent phenomena due to emergent properties of these interactions. As a final step in our research, we have asked ourselves how could we use this new knowledge to theoretically explain and practically enhance the generativity of service design. Here we have played with the idea of framing a common strategy in design to strategically form new initial concepts or design briefs by which design processes start, to provide new rules and conditions of interactions that would support actors' creative engagement. Implication of this research includes that multiplicity of knowledge of actors needs to be involved and modeled in design theory to account for service design, and also these socio-technical conditions need to be encountered. Framing was explored as a possible solution to different resistances that could occur in these interactions, and further research would need to detail the all four operators of used in design theory and validate the new extended model through use cases. Thank you, everyone. Looking forward to your questions and discussion.
Great. Thank you, all five presenters for a very good and succinct presentation of your papers. I can see that there is quite a few questions in the chat, which is of course great. So we'll start there, I suggest. I'm just going to the top here. So James Kopsil has a question for Selin. I can see James is asking to share audio, so maybe he wants to ask the question in directly.
Hello, am I on?
Yes, you are on, James. Go ahead.
Fantastic. Yes. Yeah. Thank you very much for your presentation. So you mentioned about homogeneous knowledge, and of course, you know, it's always very challenging to be able to capture what knowledge people do have. So I just wanted you to maybe to have a bit of expand on how, you know, what level of distinction could we ever achieve in understanding what knowledge different people have, and have you got any thoughts on that?
Sure. So I think it's difficult knowledge amongst all the participants of the studies we had, especially the experimental studies. However, it makes sense to write down the inclusion criteria for having similar or comparable knowledge amongst the participants. And the distinction we make is based on the task we give them. So usually in the experimental design tests we're doing, and we invite participants who are students, we try to find students who have similar or comparable technical background, or who have not worked with the tools we are testing in the experiment before, so that we do not have any deviation in the results, or there is no direct impact, depending on what they know before, on the design method's effectiveness. So that was the background. And we usually test their background, which means that how many tools did you use from the method we are testing? Did they use any before, or do they have any prior knowledge to it? If not, then that's also great. We usually do not make any distinctions in like social data of the students. So we just focus on what is required for the task. And according to that, we put the pre-tests, for example.
Fantastic. Thank you very much. Yeah, as you can see, my green screen's not working, you see. That's it.
Thank you.
That's it. My son's taken over the house. So I'm operating out of the garage.
I think you also had a question for Ola, James.
Indeed, yes. Yeah, thank you very much for your presentation as well. And one of the key challenges, I guess, with especially in the UK, is trying to. So we have like a couple of assessments for our research. One, I don't know if you're aware of it, of REF, the research excellence framework. So that's how we can then classify the impact of our research in the UK. And of course, in those, they like to see some very broad, I say, impactful statements of your research. So yeah, my question is kind of, how do we balance that idea of making claims that we can identify and validate, yet also probably to also show the potential outreach of our research and how others could apply it?
Let me, Ola, you need to be unmuted.
So,
Yes.
Yeah, mute as well. Thank you for the question. There's probably a long answer, but I'll try to take the short reply. I think the simple one is simply be aware in print and presentations that you're actually contributing to different things. If you do a knowledge contribution to a specific publication or knowledge contribution, it has to be very specific. Whereas if you do it on a broader scale for an industrial context or a governmental impact, perhaps it is useful that you can improve a broad thing by your knowledge. But I think the problem becomes when you don't make that distinction. Then you will fail in publishing, or you will have you have a claim of impact for your larger context. I think keeping both in visible and clear, I think that's the message.
cool. Cheers. Thank you very much.
Thank you, Ola. There's a question, or there's two questions to Marie-Alix. I would like to start with Sinisa's question, where she's asking, does your extended CK model and how address the generation of higher level derived design knowledge, such as design guidelines, design principles, and similar? Maybe we start there, and then there's a follow-up question. We cannot hear you right now, Marie-Alix, but you are not muted. Nicola, do you have any advice?
Yes, few of them. Actually, I think Nicolina had a similar problem in the beginning. But maybe just fast advice is just F5, try reloading the page. That might work. That solves a lot of issues. But maybe we can continue with the discussion and I can contact her directly.
I'm just going to try something else.
Smartphone connected. Do you hear me now?
Yes.
Cool.
Sorry, once again, Jaap.
Can you hear me now? Is this sound okay?
Yes, yes.
Okay. I see that Marie-Alix has reloaded. Is the sound now on or still? Okay.
So I answer the question of Sinisa. I think both. First, I just began with the current model, and we changed this model to do them alone. So in this way, it creates new guidelines, but it's not as precise as a very detailed guidelines. So yeah, it's addressed new generation of models. And in this way, it's also allow us to have new design paths. The thing is, we just did that alone in the Renault side without Google, and we find new design paths. But obviously, if we had worked with Google, we would have found other design paths, and maybe they would have been more generative, but we don't know. So I hope I answer the question. If it's not, just email me or we can speak about that later. Do we have also to answer to James now?
That's a good idea, yeah.
That's a good idea, yeah.
Yeah, perfect. So James, I hope it's for both as well for researchers studying engineering design or for practitioner. But as I am working with experts in Renault, they are professionals, so they have to use these methods. They have to apply them on real projects. Now as example, we are using these models for finding a new generative project in Renault, and we have to standardize these models, so then all the experts in Renault can use them again and again, and foster the innovation capacities of the company.
Thank you very much for that clarification. Sometimes like fine with CK theory, I don't know whether it's aimed at the researcher or practitioner. So yeah, thank you for the clarification. That's good. That's really nice.
Great for both, actually. I hope.
Great. Thank you, Marie-Alix. Then I would like to move on to questions. There's a few questions for David. Maybe we can start with your question, James. You can post it on audio if you want.
Indeed, yes, yeah. Thank you very much, David, for your presentation. Like you say, as soon as I saw the idea of this transitioning between states, or I say as states, but different physical and digital prototypes and virtual prototypes, it just immediately sprung to mind that idea of like finite state machines and state mapping. So I was just wondering if you just want to elaborate on where it's going and whether those types of methods are something that you might want to explore in how we transition during a design process.
Okay, thank you for the question. So it's not something we thought about originally, but it's not a bad idea. So we were hoping to so the next steps for us was we're hoping you're looking at real world projects, look at how designers actually transition to better understand how and why designers are, or when they transition, how they transition, and the reasons behind it, to better understand that before we started looking at sort of modeling and that side of things. So more we're hoping to have it led by what designers actually do rather than more theoretical background, because the paper itself is very theoretical. I was hoping to get a bit more real world into it.
Cool, fantastic. Yeah, so maybe a potential couple of routes once you've got that real world data. There's somehow a way of framing it or modeling it, like you say, going forward.
Yeah, so hopefully at that point we can then start going, well, you're at this part of the design phase. Your best route forward is to maybe try switching to a virtual environment or to a physical environment, and then sort of start guiding.
Mm-hmm. Awesome, fantastic, thank you.
I think there's a question from Christian on sketching. So we said with sketching, in the paper we say sketching can be both physical and virtual. And we've taken we're looking at the design from the assets or the artifacts created. So in the example I gave, talking about physical sketching on a bit of paper, because that bit of paper is physical, we call it physical, but equally, if you're sketching within a CAD package, we would call that virtual. It's more about the final artifact that you're creating, and less about, I know historically there have been questions over whether a sketch is virtual, even if it's made on paper. But yeah, we simplify by looking at the artifact created. And then the final question was on, where is it? Measure of twinning. So twinning. So we talked twinning in design gets complicated when you start looking at things like the fidelity of the artifacts you're creating. So if you have a cardboard prototype and you're aligning that with a CAD model, for example, the CAD model is always going to be in more detail and more accurate than the cardboard model you created, or a lot of the times it will be. So there's a question then of moving away from the sort of digital twin side of things where everything should be identical. When you move into design, is there an appropriate level of synchronization of fidelity that you can correctly say that your artifacts are twinned or not? But we are putting a paper together specifically on this, looking at the digital twin as a use for version control of physical artifacts. And once you have these kind of, you know, a physical artifact and you have your virtual twin of it, then you can actually start implementing version control of physical artifacts. And at any point in your design phase, you can always reprint your physical artifact and get it at an appropriate level of fidelity. Hopefully that answers your question. If not, cert design next year, the paper should be in that.
David. Nicolina, is your mic working already or not yet?
Do you hear me?
Yes, fantastic. So then we can ask you.
Okay, then it's working.
Yeah. There's a bit of lag,
Yeah,
but I think you can manage. Yeah. So if anybody in the audience has a question for Nicolina, feel free to post it as well. I was just intrigued by this idea of emergent phenomena that you're describing, and this kind of interaction space that you add in between these two spaces. And I couldn't help but think about, you know, in software development, there is this idea of beta testing where you would already put a design of something already in use, and you might actually discover that certain types of use emerge in that space. Is that something that do you think is similar to what you're describing for service, or is it something different?
Well, I think this interaction space acknowledges that there is a context to the design process. So in this sense, I can relate to what you were saying. If you think about the service design, what is the focus of our research, then you have also social dynamics between people who are interacting. There are some conditions of this interaction. So what we have seen in the CK theory that in some papers it acknowledges the environment as an existence of previous knowledge maybe, or but it doesn't acknowledge this socio-technical context, because in service design, not some abstract existing knowledge is interacting, but people are interacting, and even like the same objective knowledge can be used by different people in different contexts differently. So this is why this interaction space is important, to acknowledge these social and technical dynamics between actors, multiple actors, who are contributing how the final design will look like.
Right. Thank you. I think it's a very intriguing idea there. That's very interesting.
Thank you.
And maybe there's an additional question for you, Nicolina, that you can go into from Sinisa. Maybe can you read it in the chat, or should I read it out loud?
You can read it, please.
Okay, so the question is, a CK model is focused on design states only. Any ideas on how could CK be extended in a formal fashion as to cover generation of higher level design knowledge, such as, for example, a set of design principles?
Well, I haven't thought in this direction, but maybe it could be used in this sense as well to facilitate brainstorming of multiple of designers in generating these principles. So such as to model the final design principles will also be the result of the interaction between people who have, or designers who have different experiences in a design process. So this is my first thought, but of course, for now we didn't go in depth in this direction. But if I would go, I would think like this.
Great, thank you very much. I think Professor Weber has an interesting proposition here, so I think we'll just do that right now. Is the question here is, maybe all of you could just in one sentence or very short time state in which respect your research contributes to design knowledge. And so maybe we can just have all of you state that very briefly, that would be very interesting here. Also because this session in general is very focused on that. If anybody wants to start, otherwise I suggest that we take the order of presenters that we have. Is it okay for you to start, Selin?
Yeah, sure. So our research contribution is method developer who is in the phase of validation. And we support by giving ideas on what can come up in the validation phase with some challenges and how to cope with them.
Fantastic. Thank you, Selin. And then I think we had Ola as the next one.
I posted it also in the chat, but I think the paper designed to focus on validation help design research and also students to improve the quality of design knowledge contribution. That means in that process, but also as a means to improve communicability, to explain what you're doing.
Yeah, great. Thank you very much.
Yeah, and in short, that's also more or less the answer to the question.
Yeah. And then we had, let me check who was the next one. Was it Marie-Alix?
Yes. So my studies are focused on the fact we have experts of radical innovation management in industries, and I want to see if these experts are experts of the unknown, and if they help the other experts in industry in the unknown. So if they help them to explore, to use CK theory for instance. So yeah.
Great. Thank you very much. Then we have David.
So one of the key things to me in putting this work together was, as design researchers, we often strive to almost remove or design out the designer. So we're looking at tools that design for us. And in doing this work, I myself realized that actually it puts the cognitive model, the mind of the designer, on the same level as the physical and the virtual artifacts that we create. So we can kind of keep all those three things balanced and try and, going forward, almost keep those three things together. So in the tools we design is make sure we maintain that parity between the models that we create and use.
Great, thank you, David. And last but not least, Nicolina. Yes, sorry. Yeah.
Did you say me? Because I have interruptions. Sorry. Yeah, I would say that our research contributed in a sense that it approaches knowledge as an emergent phenomena. So as a kind of result of a process in which different people interact, and that the result is not just a combination of these knowledges of these all actors, but something which is new, something which is emergent. And you can understand this only if you understand the context. And you cannot predict it because it's not just a combination. In this research starts to explore these processes through the service design.
Great, thank you very much. So I think it's great that we have this kind of fantastic overview of your contributions. Thank you for that. We have a bit of time left. Actually, if there's no more question in the chat, I have a question also to all of you. You feel free to answer if you feel like that. So when I looked at this session in the papers, I think for me a common theme was research qualities, right? In all of the papers in some way are really about either producing higher quality research outputs through validation, for example, or really focusing on good theory building, contributing to theory rather than maybe coming up with another theory. which I think is very interesting. So my question to you is, it seems that you're all very engaged with that topic of doing high quality research. Can you maybe comment, or some of you comment on, what do you see as important challenges for improving research quality in terms of your research, or maybe important steps that we should take? I don't know if some of you want to respond to that.
Yeah, so I can have a stab at it. So recently, we're doing a lot of reading in the kind of there's more social sciencey research methods. I think I'm in a mechanical engineering department, and often it's like if it's not quantitative, then it's not real science, and it's a bit wishy-washy, and we don't really try and avoid that. But actually, a lot of what we do is more on the social side and more on people and demographics and things like that. And I think it's important that we look at these other fields, and a lot of the methodology in the social science papers go way beyond the level that I'm used to seeing in mechanical design. A lot more effort goes into the design and the expected outcomes and the analysis of those qualitative results. And I think we can learn a lot from those fields.
Great, I think that's a fantastic point to make. At least I can also see that maybe Selin has experienced that herself in the figuring out how to deal with the human side of validating methods. You've gone into that. Is there any other points? I think Ola wants to make points. We can't hear you, Ola, right now.
It is actually why we wrote our paper in the beginning, because we think that it's good to have a healthy dialogue, but it's also difficult on the validation throughout, for instance, a PhD process. It's something that everybody engages in when they write the thesis, but along the process it's a bit difficult. And especially since there are so many factors around, as one of them already mentioned, that there's a social and a scientific mix. But yes, to introduce in some practical way the notion of validation very early on. You can validate your expectations or requirements, problems as well as your results. So bring that kind of in somehow along the process would be quite good.
Great, yeah. Fantastic. Anybody else want to add to that or contradict or?
Yeah, maybe one more. Sorry. Maybe one more idea. I mean, when we're dealing in social sciences with people, it's sometimes hard to find a reason why validation in a good way or in a bad way, because people are not machines. So it is not easy to systematically describe the human being. And maybe we can also think of more documentation standards or rules or some conventions that make the studies we are doing in product development more replicable.
Great. The replicability is also a very important aspect. Nicolina, can you hear us by now? Or is the sound still off? It seems that you're not able to hear us.
Your question and the sound is interrupting all the time. So sorry if I skip this answer. Yeah.
Totally fine. I'm sorry that there are technical difficulties. Is there anyone other questions or other comments to make? Otherwise, I think we can wrap up and get ready for the final closure of the conference. I think at least I was very pleased with very good presentations and very good papers in this session and a good discussion. Really great. So thank you all very much for your contribution to this session. And then I wish you a great closure for today. And hope to see you also in real life at some time. Hope maybe at the ISET conference where Ola is hosting us.
You're all very welcome.
Great. Okay, thank you very much, all of you.
Thank you a lot.
Bye.
Thank you.
Bye.
Thank you. Bye.